Okay, welcome back to the second part of stoichiometry. This is going to deal with limiting reactants. So, a limiting reactant is one of your two reactants in this reaction, silver or sulfur, that gets all used up. There's none of it left over. It's the one that defines how much product can possibly be produced. So in this example, I'm starting out with two known quantities, 21 grams of silver and 8 grams of sulfur. So in the previous segment, I talked about the fact that it mentioned one reactant was in excess, so you didn't have to worry about the second reactant. But when you're working with limiting reactants, you have to worry about the amount of the second reactant. And so we're going to find out, we're going to go through the process for determining what's the limiting reactant. So really what you do is you run the stoichiometry, the dimensional analysis, for both amounts of the reactants, the same way that I did in the last segment. So in this one, I take my 21 grams of silver. I use my molar mass set up this way so that the grams above the dividing line cancel grams below. Then I look at the mole ratio between my silver and my product, my silver sulfide, and it's a 1 mole to 2 mole ratio. And then I'm going to use the molar mass of the silver sulfide, my last step. I calculated incorrectly at first. So I do my calculation, 21 divided by 107.87 times 1 divided by 2 times 247.8. And I get 24.12 grams of Ag2S. All right. I haven't made this conclusion yet. We'll go back to that in a minute. So then I take my second reactant, 8 grams of sulfur, and I run the same type of calculation. This time I'm going to convert the sulfur to the moles. Then I'm going to look at the mole ratio between silver sulfide and sulfur, and I look up at the equation, and it's 1-to-1 ratio, the assumed 1 coefficient there. And then I'm going to use the molar mass again of the Ag2S for every 1 mole of Ag2S. And then I'll run the calculation, this time the 1-to-1 ratio here, and I'm going to end up with an answer of 61.8 grams of Ag2S. So here's the analysis that you do to determine which one of your reactants is the limiter. The reactant that produces the least amount of product is your limiting reactant. So what you do is you go to the two amounts that you calculated, and you choose the lowest one. 21.12 grams is smaller than this. So what I know is that this becomes what I call the theoretical yield, or what we call the theoretical yield of the silver sulfide. And that amount of yield is produced by the limiting reactant. So in this case, the 21 grams of silver is the limiting reactant. And so I've crossed this number out. I'll never use it. It's just calculated for your analysis sake. So if I made the mistake of saying this is limiting, what I'm effectively saying is that the reaction is going to continue even once all of my silver is used up, which is virtually impossible, right? It goes against the law of conservation because look, it's just a ridiculous answer here. 61.8 grams is nowhere near possible that 21 grams of something and 8 grams of something could create so much extra matter or any extra matter. So here I just defined it. Since the first answer or the solution produces only 24.12, then the 21 grams of silver is called the limiting reactant. And then the 24.12 that I produced here, that I calculated here, is what I call the theoretical yield. And theoretical yield is the expected amount that you would actually get. So if 21 grams of silver is a limiting reactant, then the sulfur is called the excess reactant. I'm going to stop there. In the next video, we'll talk about the excess reactant.